Hello children, welcome to our numerals lesson today. This lesson was produced by Rwanda Education Board with support from UNICEF. My name is Teacher John. This is a primary 5 lesson from Unit 3 Mathematics. For purposes of revision, primary 6 pupils can also participate in this lesson. As usual, we encourage you to support the children during this radio learning program. Dear children, in this lesson, you will still need a notebook and a pen. Dear children, for more practice and exercises about today's lesson, you will refer to a textbook titled Mathematics for Rwandan Schools, Pupils Book 5, Unit 3, page 34. Now children, let us review what we learned in the previous lesson. What did we learn in the previous lesson? Very good. In the previous lesson, we learned about finding the lowest common multiple, which is the LCM of 2 or 3 numbers by prime factorization. We learned that to find the LCM, we keep dividing the numbers with prime numbers, starting with the smallest until all are reduced to 1. We then multiply the prime factors used to reduce the numbers. The product of the prime factors used is the LCM of the numbers. Dear friends, you remember I left you with a homework. Let us check the answer for your homework in the previous lesson. I asked you to find the LCM of the numbers 4, 5, and 10 by prime factorization. If you followed the procedures very well, I'm very sure that you got the LCM of 4, 5, and 10 as 20. If you didn't get 20, you can try it out again until you get 20. For those who tried out and have gotten it right, well done. Dear children, and in today's lesson, we will learn to find the greatest common factor, abbreviated as GCF, sometimes also called highest common factor, HCF. But first, let us have a short break. We will be back.
Come along and play with us.
Welcome back, dear children. Like I said before the break, in today's lesson, we will learn to find the greatest common factor, GCF, sometimes called the highest common factor, HCF. Finding the GCF or HCF requires us to remember our prime numbers. It is on that note that we are going to have a warm-up song to remind us of our prime numbers. Are you excited about it, children? Great! Do you remember our prime number song, children? Okay, great. I know you do, because we have practiced that song several times. But again, I will sing first, and we will then recite it together as you dance in any way you wish. Are you ready, children? Very good, let's go. I am prime, Prime. My factors are only 1 and me. Only 1 and me. and I am 2, 3, 5, 7, 11, 13, and so on. And those are my prime numbers. Dear children, can we now recite our prime song together as you dance in any way you wish? Ready? Let's go. I am prime, P-R-I-M-E. My factors are only one and me. Only one and me. And I am 2, 3, 5, 7, 11, 13, and so on. And those are my prime numbers. Well done, children. You may now take your seats. I hope you're now ready to learn. Dear children, let us remind ourselves what factors are. What are factors, friends? Very good. Factors of a number are numbers that can divide it evenly. That means those are the numbers that can divide it without any remainder. Dear friends, from what we have heard about factors, that means that the GCF of numbers is the highest number that can divide all those numbers without a remainder. Now, friends, to find the GCF of two or more numbers, we do the following. Note them down in your notebooks. We start by dividing with the smallest prime factor that is able to divide all the numbers. Secondly, we continue dividing until there is no any other prime factor that can divide all the numbers. And lastly, the GCF or the HCF is the product of those prime factors we used. Remember, those are the prime factors that are able to divide each and every number whose GCF we are to find. We will have examples after this short break.
Come along and play with us.
Welcome back, dear children. Like I said before the break, we will now have some examples of finding the greatest common factor of numbers. Activity 1. Find the GCF of 18, 12, and 24. Okay, dear children, you will follow the steps. In our procedures, we start by dividing the numbers with the smallest prime factor that can divide them. For example, in this case, the numbers 18, 12, and 24 can be divided by the prime factor 2. Therefore, let us start by dividing the numbers 18, 12, and 24 with prime factor 2. We get 18 divided by 2, we get 9. 12 divided by 2, we get 6. And 24 divided by 2, we get 12. Our numbers have been reduced to 9, 6, and 12 respectively. 2 can no longer divide in 9. Therefore, we move on to 3. 3 can divide in 9, 6, and 12 to get 3, 2, and 4 respectively. 9 divided by 3, we got 3. 6 divided by 3, we got 2. 12 divided by 3, we got 4. Very good. Now, so far we have used two prime factors. That is 2 and 3. Now, dear friends, our numbers 18, 12, and 24 have been reduced to 3, 2, and 4. There is no any other prime factor that can divide 3, 2, and 4. There is no any other common divisor for 3, 2, and 4. Therefore, we do what? We stop. That means we have only used prime factors 2 and 3. And that brings to our GCF. The GCF of 18, 12, and 24 is 2 times 3, which is equal to 6. Children, we used only 2 prime factors. We used 2 and we used 3. And we said that to get the GCF, we find the product of those prime factors that could divide all the numbers. Therefore, the GCF of 18, 12, and 24 is 2 times 3, which is 6. Very good. Now, friends, let us have another example. It will make us understand better how to find the GCF, or the greatest common factor of numbers. Activity 2. Find the greatest common factor, which is the GCF of 42 and 48. Dear friends, following the same procedure, we can see that the prime factor 2 can divide both 42 and 48 to get 21 and 24, respectively. We can see that 2 can divide 42 and 48 to get 21 and 24, respectively. As you can see, 42 divided by 2, you get 21. 48 divided by 2, you get 24. Friends, the same prime factor 2 can no longer divide 21 and 24. Therefore, we move on to another prime factor 3. Dear friends, can 3 divide both 21 and 24? Yes! 3 can divide 21 to get 7, and 3 still divides 24 to get 8. 3 can divide both 21 and 24 to get 7 and 8, respectively. Now our numbers 42 and 48 have been reduced to 7 and 8 with the prime factors 2 and 3. Friends, is there any other common divisor for 7 and 8? No, there is no any other common divisor for 7 and 8. Therefore, we stop dividing. Now, friends, what is the GCF of 42 and 48? Very good. The GCF of 42 and 48, which is gotten by multiplying the prime factors we used to divide them, is equal to 2 times 3, which is equal to 6. Remember, only prime factors 2 and 3 were able to divide all the numbers. Very good. That is why our GCF of 42 and 48 is the product of 2 and 3, which is 2 times 3, which is equal to 6. Now, friends, let us have a break. We will be back shortly.
Come along and play with us.
Welcome back, children. I'm glad that you're still with me. Now, children, you can try out this exercise on your own. Find the greatest common factor, which is the GCF of the numbers 9, 18, and 27. Dear parents or guardians, help me to see whether my friends are progressing well. Dear children, you have few seconds to do this. Very good. Now, let us check our answers. The prime factor 2 cannot divide all the numbers 9, 18, and 27 without a remainder. Moving on to the next prime number 3, we can see that it divides all the numbers 9, 18, and 27 to get 3, 6, and 9 respectively. 3 divides all the numbers 9 to get 3, 18 to get 6, 27 to get 9. Therefore, 3 is one of our common divisor. Again, 3 can divide the new numbers 3, 6, and 9. 3 can still divide the new numbers we have gotten 3, 6, and 9 to get 1, 2, and 3 respectively. 3 divided by 3 we get 1, 6 divided by 3 we get 2, and 9 divided by 3 we get 3. Friends, that is the second 3 as a common divisor. There is no any other prime factor that can divide all the numbers 1, 2, and 3. Therefore, we stop. Dear friends, which common divisors did we use? Very good. We used 2 common divisors, and those are 3 and 3. Dear friends, we used 2 3s as our common divisors. Therefore, the GCF of 9, 18, and 27 is 3 times 3. And this is equal to 9. And therefore, the greatest common factor of 9, 18, and 27 is 9. Those who got it right, well done. And if you didn't get it right, thank you for trying out. Do revisit your work and check where you went wrong. Well done, friends. Before we end our lesson, let us review what we have learned today. We have learned to find the greatest common factor of numbers. We learned that we divide starting with the smallest prime factors that can divide all the numbers. We called these ones the common divisors. We then multiply all the common divisors, and those are the prime numbers that could divide all the numbers, to get the greatest common factor or the highest common factor, abbreviated as the GCF or the HCF. For your homework, friends, find the GCF or the HCF of 15, 30, and 35. That is it for today. Thank you for participating. Remember to join us for our next numeracy lesson. Bye-bye.
Goodbye, 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 teacher. Goodbye, children. See you